influenceable element in the mix, and we have to co-optimize those two things. So it's not about supply existing in one corner of the utility and customer forecast and knowledge of the customer base sitting somewhere else. Those two things are intimately connected. So as I think about sort of this smart grid challenge as it relates to renewable integration, it's, to me, the big picture of opening up this black box called the utility, and inside are a bunch of disparate systems that now all have to communicate with each other. Some of those systems are aware of the injection of electrons into the grid. Some of those systems are aware of the outtake, the consumption by consumers. But the reality is we have to keep those things balanced in real time. And that's why this has been a historically kind of command and control, heavily centralized industry. Now, as was mentioned, it's becoming much more like IT or telecommunications, a networked two-way model. And that's very, very challenging for that kind of real-time balancing capability. So the automation, when people talk about smart grid, they're usually thinking in terms of the digital intelligence that resides on top of the power system. And that's, the automation is an attempt to capture and represent the realities, the physical flow of power in a way that allows, a more intelligent control. And again, I shy away from the word control, influence on things like intelligent customer end use. So if customers can reduce or avoid consumption cheaper than we can bring fast ramping resources online to buffer a wind resource perhaps when the wind dies down, then by all means we want to know about that, we want to take advantage of it. But the response rate for a customer to get a price signal through their thermostat and undertake some change in behavior is probably a little different than the automated generator control that we use today, literally faster than the human eye can blink to ensure that the frequency of the grid stabilizes in real time. So, there are real concerns about grid reliability. I guess, repeat my themes. Silos are being broken down. That's a good thing. We are learning to play with a much bigger toolkit than historically the electric industry has been able to play with. And I won't even touch on the gas side, but I think there's interesting opportunities with CHP as well, and integrating thermal load into the equation. And we have to co-optimize. And we can't just think in these siloed ways about optimizing one resource over here, getting the best out of our solar, and then separately getting the best demand programs in some other department of the organization. We're now really looking at the synergies.
Good afternoon, everyone. Farmers Mahsul, I'm Director of Smart Grid Solutions at Cisco Systems. A little bit of background. I have my PhD in electrical engineering, so I look at this not from information technologies and communications, but rather from the point of view of electrical engineering and how to run the grid. I've spent my entire career looking at grid reliability, grid operation, grid planning. You have probably heard of Cisco. Cisco is an information communication technology company. We don't build generators, transformers, switch breakers, or any of the grid assets that generate electricity. But where we think we can add value is this overlay of information and communication that's going to be sitting on top of the physical grid, so that for all the challenges that my colleagues mentioned, this complexity that's going to be inherent in rolling in renewable energy, especially at the distributed scale, onto this system that has been operating reliably for more than 100 years, these challenges are not trivial. You heard the term optimization mentioned many, many times, the panel before this one and this panel as well. So the fact of the matter is that up to this point, because of the way we had used electricity and we had generated electricity, we could do with a centralized control or optimization of the grid. So you have a control center looking at everything that's going on, consumers very nicely consuming electricity, not producing anything, And so we established these methodologies to control the grid with the changes that Brian pointed out on the chart that you can see. You're going to see flow of electricity in multiple directions. You're going to see intermittency, renewables, larger scale, smaller scale, and whatnot. So the challenge that we have is, first of all, we have to break down the silos of information, get information across between different departments of the utility. And this information is not just between people who need to communicate, but rather machines. So it has to be extremely fast, extremely reliable. That is part of what we do and many other companies, by the way. We are trying to see how we can facilitate this information exchange across the grid. But that's the easy problem. We have solved that problem in other industries. Industries with even more stringent data requirements. But the challenge with the grid is that you have to find a substitute for this centralized scheme of optimizing everything. So if you think you can optimize things, for example, at the building level, well, that's good for the building owner and the occupant, but that's not good for the grid. You can look at this campus and start optimizing one building at a time. You look at it at the campus level, because some buildings lend themselves to efficiency better than some other ones. So as we look at this distributed way of looking at this system of systems that Matt mentioned, there has to be a scheme where you can optimize it so that it is globally reliable, but also from the point of view of the consumer, it's comfortable, convenient, secure, private. So this trivializing the notion of customers running to their thermostat to switch them or shift them left and right just because the price went up or down, that's more of a joke, right? We don't expect that to happen. So this has to get to a point where you almost, you don't see the effect of the smart grid. It just operates in the background and it does what you expect it to do. So the natural way to break down the problem just turns out to be something that is very natural to the physical layout of the grid. So as the power comes from the generators all the way to the end users into this building, there are places in the grid where there are hubs of power. They're called substations. And these substations are places where utilities manage the quality of power, the voltage, the frequency, the various aspects that you would see, like flicker and whatnot. So if we can put some intelligence into these substations, we can then manage local resources better. So if you have a rooftop solar, you don't need to send whatever watts it generates all the way to the control center for the operator over there to decide between millions of rooftop buildings in California, which ones I'm going to use now, which one is going to turn off the refrigerator or whatnot. This is going to be aggregated at a lower level within a substation. Now what is interesting and I guess fortunate is that these substations also correlate geographically to the size of a community, the size of a campus. So while on the electrical engineering side of things, we are interested in optimizing the system at the substation level, from the consumer's perspective, from the community's perspective, the business model, the commercial model, the community model for accepting a smart grid is going to be addressed at the community level. So you don't go to a whole community and go door to door and say, do you like smart grid? Can we give you a smart meter? And you rather escalate it up to a level where there is representation, both politically, economically, and common interest. And that just happens to be, by pure luck, corresponding to the substation level where the utilities look at their grid. So that may just unlock the mystery that we have, so that we can address reliability and we can address consumers' concerns. So those are the two thoughts I just wanted to leave you with. So there is hope, and hopefully these smart meters that we all are going to be paying for are going to help us in the future.
Great. My name is Blair Sweezy. I am a Director of Market Development and Public Policy at SunPower Corporation. SunPower is a manufacturer of high-efficiency silicon PV panels. And we operate in all market channels here in California and around the world. We have 180 dealers in California that we supply systems to for residential and small commercial systems, and then